All right, now there's a formula in your book. And again, I'm going to tell you, don't worry about the formula. Don't memorize the formula. Think it through, and if you understand it, it'll be easier to remember. Okay? So you might also be thinking to yourself, all right, how often am I going to be asked to figure out the number of ways to arrange the letters in a word? And you're right. Um, maybe not that often, but it turns out there's a number of analogous problems that turn out to be essentially the same as letter arrangements. So if you learn how the letter arrangements works, then you can solve these analogous problems as well. So these next three examples are really just problems that are analogous to the letter arrangement problems. Okay, so let's take a look at example 12. All right, so Bill works in New York City. He gets off the subway at point B and walks 7 blocks, 3 blocks north and 4 blocks east to his work at point W. How many 7-block paths can he take to work? All right, so if we're going to restrict him to 7 blocks, we're not going to allow him to walk in circles and stuff like that, then essentially he has to go 3 blocks north, right? I could call that N, so he's got to go 3 blocks north, right? So he could do that on maybe he could go up, that 3 blocks north and 3 blocks east, or he could go east and north and east and north and east and north and east. You know, he could do it that way. He could go east, 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 and then north, north, north. But he's got to have some combination of 3 northerly paths and 4 easterly paths, okay, to get there, okay, in any order he really wants to. So it becomes a matter of just looking at 3 northerly blocks and 4 easterly blocks and just arranging those paths in some way. And if you write it out like this, where he's got to go do some combination of N north moves and east moves, then it just becomes a letter arrangement problem, right? Because you could treat this as a letter, or sorry, a word, N, 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 E, 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 E. And then we're just looking for the number of ways to arrange that, okay? So again, we're just going to treat it just like we did the other letter arrangement problems. We have 7 factorial ways to arrange 7 letters, but then we have 3 factorial ways to arrange the N's and 4 factorial ways to arrange the E's. Okay, and if we write that out, it's 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 4 times 3 times 2 times 1. Now you can see here that all this cancels, right? And then 3 times 2 times 1 is 6. So all we're left with is 7 times 5, which is 35 paths. Okay, so he has 35 ways to get from the subway station to his work.